So here we go with series. Again, the idea behind a series is we're taking a sequence, all right, and we're taking all of the terms of the sequence and we're trying to find the sum. All right. So now our sequence, remember, that could be a finite sequence or an infinite sequence. All right. Take the sequence 2, 4, 6, 8, 10, 12, so on and so forth. Okay. So what if we wanted the sum of the first, whatever, 5 terms? All right. So it would be the second term, the first term plus the second term plus the third term. Actually, what did I say? 2, 4, 6, 8, 10. 6 and 8 plus 10. So we want the sum of those 5 terms. All right, so we can see that that's going to add up. Right, so we get 6 plus another 6 plus gives us 12 plus 8. So we have a total of 30 there as our sum. Okay. Well, we just found a series. We found the sum of the first 5 terms of the sequence. Okay. And then that sequence may go on forever, or it may not. Okay. We'll talk more about that in a second. But because ultimately what we're trying to do is add up some terms. Okay. So when we're adding up terms, and we know this from earlier math classes, what's that Greek symbol that helps us to show that we're trying to find a sum? Exactly, it's sigma. All right, so we have sigma right here. Right, and that means we're adding up the terms. The terms of what? The general sequence. So when we're adding something up, the general term of what we're trying to add up goes after the sigma notation. All right, and then the idea is, well, what are we adding up? Well, as n starts off, and n could start on any number that we want to. Quite often it's 1, and if it's not 1, it's 0. But n could start at any term. All right, and then it goes to any value that we want. Okay, so we could have, well, we just want the first 5 terms, all right? So that means we're going to do a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5, and boom, we'll call it a day. Okay, that's a finite number of terms, and that's fine, but that's not really where we're going with all this. We're more interested in what if we can find the sum of all the terms, okay? And therefore, we have an infinite number of terms, or an infinite series. Okay, what's the sum of all the terms? All right. And if you think about that for a moment, well, can it actually be found? All right. Well, if we look at go back to our first example. All right, we had 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus so on and so forth. If we keep adding values, are we ever going to get some kind of limit to what our values, our sum's going to be? No, we're not, okay? So that's a situation where we have a series which diverges, okay? It does not converge. There's the other key word, converge to a specific value, right? So what we're looking at here with these series is, and specifically with these infinite series is, can they converge to a single value, right? We need to figure that out. And that's where this next group of videos is going to be heading is, okay, well, what sort of tests or what sort of tools can we use to determine whether these infinite series will converge or not? Because not all series, especially the ones that we're interested in, are going to be like this one down here, which we can easily determine that they diverge. There's a lot more complicated series, and we want to know, do they converge? And if so, what do they converge to? So that's what's coming up next.